Welcome to this programming tutorial. Today we will be looking at 2D array data structures. Last lesson we were looking at 1D arrays. This means that we had arrays that stored one value per index, or one value per slot. But did you know that you can store an array inside an array? Almost like using nested arrays. This can be useful when you want to link two pieces of data together, for example, a student's name and their grade. Let's look at creating our shopping list again, except this time we will add the prices as well. Let's create a 2D array. We start by creating an array data type. In this case I will create a string array. The difference here is that I will add a comma in the square brackets to indicate that this is a 2D array data structure. Then I will create the rest as normal. To add values into this array, we create smaller subarrays inside. Let's add a smaller array for apples, which costs 90 pence. Oranges, which cost 80 pence. And pears, which cost 99 pence. Now, how could we output oranges? Let's output the array with the index 1 to specify the second data structure, i.e. the one containing oranges. As you can see, the normal method of outputting is incorrect. Remember the comma we specified before? We now have two indexes to specify. The first index specifies which subarray we want to output. In this case, we want the second array, so we will use 1 as the array ordering starts at 0. Next, the second index specifies a value in that subarray. Like before, the ordering starts at 0, so to get oranges we will specify index 0. If we run the program, you can now see that we get oranges outputted. Modifying the subarrays works the same way as normal arrays. The difference is that you need to specify the subarray and then the data, i.e. you need to always use two indexes. In this example, I am changing the price of pears to £5.40. As before, we can use a count-controlled iteration to loop through all the data, except we have a little problem. The index that we use in this iteration will count up to 3 items, as we have 3 items in the array. This will cause an error, as we only have 2 items in these subarrays. To fix this, we can use nested iteration to go through the subarrays. Please note that to get the length of all the arrays and all the subarrays, we are going to have to use .getLength instead of .length. .getLength 0 will return the size of the first index, i.e. the subarrays. .getLength 1 will return the size of each subarray. As you can see, we use the index I to grab the current subarray, and then we use a nested iteration to run through the length of that subarray using I as our index. In the nested iteration, we have a new counter variable which we can call j. Then, inside the nested iteration, we can output each item using the I to specify the subarray and the j counter variable to run through the subarray. As you can see, it outputs as intended. Let's look at a list in picture format. The I rows specifies different sublists, and the J columns represents each data in the subarrays. The rows are our first count-controlled iteration, while the columns are our nested second count-controlled iteration. When we start, the program runs through each item in the row. Once it gets to the end, it moves to the next row and J starts at 0 again. It continues doing this until it gets to the last item. This is how our 2D array iteration works. Like before, we can also specify a 2D array that is empty. To do this, create a 2D array as normal. I'll create an empty integer 2D array, using the comma to specify that it is a 2D array. I will then assign it a new integer array, and then I'll specify the size of each subarray. In this example, we have created a 2D integer array with 100 subarrays, and each subarray has 5 empty slots in it. Like before, remember that 2D arrays cannot have their size changed. This is true for the amount of subarrays it has, as well as the size of each subarray. Thank you for watching this tutorial. I hope you have found it helpful.